Welcome to CSEGuru. In this session, we will discuss Quantitative Aptitude by S Agarwal and the topic is Numbers MCQ Part 19. Problem number 91. If the number 4253 star is completely divisible by 72, then which of the following number should replace the asterisk? So the divisibility rule by 17 is the number should be divisible by 8 and 9. So the divisibility rule for 8 is last 3 digits should be divisible by 8. And the divisibility rule for 9 is sum of its digits should be divisible by 9. So for this asterisk, we will apply these 4 options and we will check whether it is divisible by 8 and 9. So option A is 42573 and A value is 4. And option B is 42573 and B value is 5. Option C is 42573 and C value is 6. And option D is 42573 and D value is 7. So first we will check the divisibility by 9 and then we will check divisibility by 8. So for divisibility by 9, sum of the digits should be divisible by 9. That is 4 plus 2 plus 5 plus 7 plus 3 plus 4. So this should be divisible by 9. So it is 24. It's not divisible by 9. If it is divisible by 9, then we will check the divisibility for 8. Then next option is 4 plus 2 plus 5 plus 7 plus 3 plus 5. It is 26. It is also not divisible by 9. Next is 4 plus 2 plus 5 plus 7, 3 plus 6. So this is 27. Yes, it is divisible by 9. And the divisibility rule for 8 is last 3 digits. That is 7, 3, 6. Whether it is divisible by 8. Yes, it is divisible by 8. And also we will check for option D. That is 4 plus 2 plus 5 plus 7 plus 3 plus 7. And it is 28. No, it is not divisible by 9. So the correct answer is option C. Star is equal to 6. Next, problem number 92. Which of the following number is exactly divisible by 99? So if a number should be divisible by 99, the rule is it should be divisible by 9 and 11. So we need to check these 4 options whether it is divisible by 9 and 11. So for the divisibility rule for 9 is sum of its digits should be divisible by 9. So its sum is 18. Yes, it is divisible by 9. And divisibility rule for 11 is sum of the odd digit minus sum of the even digit value should be either 0 or it is divisible by 11. So sum of the odd digit is 1 plus 4 plus 4 minus sum of the even digit is 1 plus 3 plus 5. So its difference if you are getting, this is 9 minus 9, that is 0. Yes, it is divisible by 9 as well as 11. Similarly, we will check for other 3 options also. It is divisible by 9, not divisible by 11. And option C if you are checking, so the total value is 27. Yes, it is divisible by 9. 18 minus 9, we will get it as 9. No, it is not divisible by 11. Next option D, so the value is 25. So it is not divisible by 9. So the correct answer is option A, 114345. It is divisible by both 9 and 11. So it is divisible by 99. Next, problem number 93. The digits indicated by star and dollar in 342213 star dollar. So that this number is divisible by 99. And the star and dollar value are given in the options. So the divisibility rule for 99 is it should be divisible by both 9 and 11. So we will apply these 4 options and we will check whether it is divisible by 9 and 11. So option A, if you are checking, 342213, and the total sum for this value was 17. And here we will apply, instead of this star and dollar, for option A we will apply 1 and 9. So its sum is 17 plus 1 plus 9. This is divisibility rule for 9 and this is divisibility rule by 11. So its sum is nothing but 27. Yes, it is divisible by 9. And the divisibility rule for 11 is sum of the odd digit minus sum of the even digit. We should get either 0 or the number should be divisible by 11. So sum of the odd digit is 3 plus 2 plus 2 plus 3 plus 9 minus sum of the even digit is 4 plus 2 plus 1 plus 1, and its value is 19 minus 8. So it is 11. Yes, it is divisible by 11. So the option A is divisible by both 9 and 11. And we need to check for option B, C and D also. So option B, if you are considering, this is 342213, and instead of star we will apply 3 and instead of dollar we will apply 7. And its total value was 17 and star value was 3 and dollar value was 7. So it is also 27 as it is divisible by 9. And the divisibility rule by 11 is 3 plus 2 plus 2 plus 3 plus 7. This is the sum of the odd digit minus sum of the even digit is 4 plus 2 plus 1 plus 3. So it is 17 minus 10. So it is 7 and it is not divisible by 11. So option B is wrong option. Option C, if you are checking, 342213 and star value is 4, dollar value is 6. So 17 plus 4 plus 6. It is 27. Yes, it is divisible by 9. And the divisibility rule by 11 is sum of the odd digit is 3 plus 2 plus 2 plus 3 plus 6 minus sum of the even digit is 4 plus 2 plus 1 plus 4. And the value is 16 minus 11. So the value is 5. So it is not divisible by 11. And if you are checking option D, 342213 and star value is 5 and dollar value is 5. So it is 17 plus 5 plus 5. So the value is 27 only, and all these 4 options is divisible by 9. Only we have to check whether it is divisible by 11. So the divisibility rule for 11 is 3 plus 2 plus 2 plus 3 plus 5 minus 4 plus 2 plus 1 plus 5. So the answer is 15 minus 12. So answer we will get it as 3. It is not divisible by 11. So the correct answer is option A. Star value is 1 and dollar value is 9. Next, problem number 94. If x and y are 2 digits of the number 653xy such that this number is divisible by 80, then x plus y is equal to. So the given number 653xy, that is divisible by 80. Then we need to find x plus y. So the divisibility rule for 80 is the number should be divisible by 5 and the number should be divisible by 16. And the divisibility rule for 16 is the number should be divisible by 2 and the number should be divisible by 8. So if you are considering here, this particular number should be divisible by 5 as well as 2 as well as 8. So if you are considering here, the number should be divisible by 5 in the sense its unit digit should be either 5 or 0. Then that particular number is divisible by 5. And if you are considering the 16th table, we never get unit digit as 5 and we will get the unit digit only 0. So we can conclude that y value should be 0 only, it never be 5. So we have concluded y value is equal to 0. Then we need to find x value now. Now x value, we will apply these 4 options and we will check it. So option A, 653, and x value we consider it as 2, and y value 0 for all the options. And B option, if we are considering, it is 65330. And option C, it is 65340. And option D, it is 65360. So now if you are considering, since the unit digit is 0, all these options will be divisible by 5. And all these numbers, if you are considering, since the unit digit is 0, it is divisible by 2 also. So now we need to check the divisibility rule for 8. So the divisibility rule for 8 is last 3 digits should be divisible by 8. And if you are checking here, the last 3 digit is 320. Yes, it is divisible by 8. Option B, if you are checking, it is 330. It is not divisible by 8. Option C, if you are checking, the last 3 digit is 340. It is also not divisible by 8. And option D, if you are checking, last 3 digit is 360. It is also not divisible by 8. So the correct option that is divisible by 5, 2 and 8 is option A. So x plus y is equal to. So x value is 2 and y value is 0. So we will get 2 only. So x plus y is equal to 2. So the correct option is option A, 2. Next, problem number 95. How many of the following numbers are divisible by 132? So the divisibility rule for 132 is the number should be divisible by 3, 4 and 11. So the multiplicity value for 132 is 3, 4 and 11. So the given number, if it is divisible by 3, 4 as well as 11, means that particular number is divisible by 132. So the first number is 264 and the second number is 396, 462, 792, 968, 2178, 5184, 6336. So first number, if you are checking, so all the numbers, if it is divisible by 3, means sum of its numbers should be divisible by 3. So first we will check all the numbers whether it is divisible by 3. If so, then we will check whether it is divisible by 4. If so, then we will check whether it is divisible by 11. So first is divisible by 3. So its sum, if you are considering, it's 12. Yes, it is divisible by 3. Next sum is 3 plus 9 plus 6. It is 18. And third sum is 12, 18, 23. And this sum is 18. And the next sum is 18. And if you are considering here, this 23 is not divisible by 3. So obviously this number is not divisible by 132. And the remaining numbers, all it is divisible by 3. And next, divisibility by 4, if you are considering, the number 264 is divisible by 4. And 396 is divisible by 4. And 462, it's not divisible by 4. And 792, it is divisible by 4. Then 2178, it's not divisible by 4. And next 5184, it is divisible by 4. And next 6336, it is divisible by 4. Now we will check these options only whether it is divisible by 11. So 264, sum of the odd digit is 2 plus 4 minus 6. So 6 minus 6, we will get it as 0. Yes, this number is divisible by 11. And the next number, if you are checking, sum of odd digit is 3 plus 6, that is 9 minus 9. So the difference is 0. Yes, it is divisible by 11. Next, 792, if you are checking, sum of the odd digit is 9. So 9 minus 9, that is 0. Yes, it is divisible by 11. Next, 5184. Sum of the odd digit is 5 plus 8 minus 1 plus 4. So that is 13 minus 4. So the difference is 9. So it is not divisible by 11. Next, if you are checking, its sum of the odd digit is 9 minus even digit is also 9. So 9 minus 9, the difference we will get it as 0, and this number is also divisible by 11. So the numbers 264, 396, 792 and 6336. These four numbers are divisible by both 3, 4 and 11. So it is divisible by 132. Here they are asking how many of the following numbers are divisible by 132. That is 4 numbers. So answer is option A, 4. Thank you for watching this video.